So the inside of the nerve is negative compared to the outside. When a nerve is stimulated at the dendrites, sodium moves in, sodium flows into the nerve cell. You can see that this negative collection of negative ions attracts these positive charges. So as the sodium moves in, the voltage of the cell changes. So you can have a voltmeter and measure that the inside of the cell is negative compared to the outside of the cell. But you can see these positive charges are being attracted by the negative charges that are all along the inner surface of the cell, and the movement of sodium in starts this signal generation, starts this electrical signal, and that's how messages are sent to muscles, messages are sent to glands, and this whole movement of ions in. And as soon as these sodium channels close, potassium channels are going to open, and sodium's going to be pumped out. Potassium's going to have potassium leave the cell. That's going to make the cell negative again. Okay, we'll keep going. So the nervous system sends messages to and from the brain constantly. As I talk, you hear me. I'm stimulating your eardrum, which is leading to a stimulation of the auditory neurons, which are processing my voice so that you can hear it. Visual information is being processed as you look at the screen. All that information that is collected and sent out goes along nerves by signals known as action potentials. Synapse are any junction between one nerve and the next. Chemicals allow a neurochemical to allow information to flow from one nerve to the next. Information always flows away from the cell body down the axon to axon terminals. We're constantly having information processed and taken into the central nervous system, integrated, analyzed, and the response is sent out. So when we sit down, there's a constant monitoring of our muscle locations and muscle stretching. And that information allows us to learn how to sit and not fall on our face. If we want to get up and walk, we're constantly monitoring the pressure on our feet, the position of our muscles, the contraction of our muscles. So that's a process of sensing what's happening and responding to the environment. Neurotransmitters such as dopamine, acetylcholine are involved in the transmission from one nerve to the next along the synapse. The synapse is the junction between two different nerves. It always flows from the presynaptic neuron to the postsynaptic neuron. The axon always moves away from the cell once it is stimulated, and we have the information that's sent into the central nervous system. Many of those responses are automatic, and we don't even think about them. We can change our response. We can decide to get up and sit out of the sun. So we can say it's too hot, and we're obviously feeling it. We move into the shade, and the movement in the shade comes from motor output to the muscles that cause contraction of muscles. We depend upon signals from the exterior to respond how muscles position our body and move us all about. So what does a synapse look like? We have an axon carrying a signal. When the signal gets to the end of the axon, called the synaptic knob, calcium moves in, and these vesicles contain neurotransmitters. So, for instance, acetylcholine is a neurotransmitter that stimulates muscle movement after the nerve impulse has been propagated and gets to the end of the nerve. That causes the release of a chemical, a biochemical, which will change the environment and will open up various channels to allow that electrical impulse to be turned into a biochemical response. That biochemical response can be modified by external drugs, LSD, caffeine, cigarettes, the toxins that are in cigarette smoke. We're constantly modifying our nerve output and how the biochemical messages can be changed by nicotine, caffeine. We are all very good at using plant-derived biochemicals that change what happens at these synapses. Okay, let's stop there and we'll have another recording. So let's stop recording for a moment. Stop recording.